so pre-chapter 1, which we're going to call R1, is exponents. It says exponents and radicals, but we're mostly focusing on exponents today. So repeated multiplication can be written in exponential form. So if I have a times a times a times a times a, I'm multiplying a 5 times together. So I would write that as a to the 5th power. If I have negative 4 to the 3rd power, that's negative 4 times negative 4 times negative 4. So negative 4 3 times. And then in the last one, I have 2x to the 4th power. So that is 2x times 2x times 2x times 2x. So it's 2 multiplied 4 times and x multiplied 4 times. 2x times 2x times 2x. So that would be 2x to the 4th power. Next, we have exponential notation. If a is a real number and n is a positive integer, then we have a to the nth power would be a times a times a times a, however many n times. So if I had a to the 3rd power, that would be like saying a times a times a. So n would be considered what? What do we call that little number on top? The exponent. And a would be what? The base. Awesome. And we read it as a to the power of n or a to the nth power. So we would read this as a to the power of 3 or a to the 3rd power. Or you could say a cubed. So like the 2nd power and the 3rd power are kind of our special cases. So if I had a squared, you could say a to the 2nd power or a squared. If I had a to the 3rd power, that'd be a to the 3rd power or a cubed. When multiplying exponential expressions, if I had a to the power of m times a to the power of n, what would I do to the exponents? I add them, just like it did here. So when the base is the same, you add the exponents. So it did an example for us. We have x to the 3rd power times x to the 4th power. So I would add 3 plus 4, which would give me x to the 7th power. What if I had x to the 2nd power times x to the 5th power? Awesome. I add the exponents. So this would be x to the 7th power. It says example 1, but we have 6 examples on this page. So we're going to do A, C, and E. Just go straight down. So I have 3 to the 2nd power times 3 to the 6th power. My base is the same, so what do I do to the exponents? Add them. So it's 2 plus 6. 8. So this would be 3 to the 8th power. Now C is a little bit different. Before I can combine my variables together, what should I do first? What do you mean by that? What would I multiply first? I multiply the coefficients. So I would multiply the numbers out front first. So what's 5 times 2? 10. And then I could do x to the 3rd power times x to the 4th power. How would I multiply those together? What do I do to the exponents? Add them together. So this would become what? x to the 7th power. So 10x to the 7th power. Okay, right, let's take a look at E. So when I'm multiplying, if I have parentheses and nothing, like no exponent on the parentheses, nothing being multiplied out front, I don't have to distribute anything here. So I can just get rid of the parentheses. It's m to the second power times n times m times n to the fourth power. Now, how would I multiply these together? So I start with the bases that are the same. So I have m squared and m. What's my exponent on that m that doesn't have an exponent? 1. And what do I do to the exponents? Add them together. So this would be m to what power? M to the third power. And then I do the same thing to the n's. So my n here that doesn't have an exponent, what would the exponent on that be? 1. So I have 1 and 4. What do I do to those exponents? Add them. So it would be n to what power? The fifth power. When writing your answer, you want to put it in alphabetical order. So like if I had x and y's being multiplied together, I'd put the x's first, then the y's. So just like here, I put the m's before the n's. It kind of doesn't matter because when you're multiplying, it doesn't matter what you multiply first. But it's just, on the SAT, you'll always see it in alphabetical order first. All right, so F, what would I multiply first? The 3 and the 4. Multiply your coefficients first. So what's 3 times 4? 12. What would I multiply next? The y's. So how would I multiply y to the third power times y to the fourth power? Awesome. We add the exponents. So that would be y to the seventh power. And then I have the z's. What's my exponent on that first z? 1. So what do I do to the exponents? Add them. So what's 1 plus 2? 3. So this would be z to the third power. So let's take a look at b. So we have b to the third power times b to the fourth power. So when our bases are the same, we add our exponents together. So this would be b to the seventh power. For d, we start by multiplying. So we have negative 2 times 6 would be negative 12. And then p to the fifth power times p to the fourth power. We add the exponents together, so that would be p to the ninth power. All right, example 2. It looks a little bit trickier because we just have another term in there, but we're doing the same thing. Just multiply our like terms together. So what do I start with? Start with the numbers first. So I have 3 and negative 2. Do I have any other coefficients? The negative 1 here. So if I have a negative x, it's like saying negative 1x. So I'd multiply that also. So I have negative 1 times 3 times negative 2. What's negative 1 times 3 times negative 2? 6. Positive 6 or negative 6? Positive, because a negative times a negative is a positive. What do I do next? What do I do next? The x's. So I have x squared times x to the third power. So x squared times x to the third power. What's the coefficient on that middle x? 1. Remember, if nothing's written there, it's coefficient, or it's an exponent of 1. What do I do to the exponents? Add them together. So 2 plus 1 plus 3 is 6. So it would be x to the 6th power. And then lastly, we look at the y's. So I have y to the 3rd power times y to the 2nd power times y. What would the exponent on that third y be? 1. What do I do to the exponents? Add them. So when you're multiplying, add them. What's 3 plus 2 plus 1? 6. So it would be y to the 6th power. So 6 times x to the 6th power times y to the 6th power. Any questions here? Right, let's do B also. What do I start with for B? The numbers. So I have 5 times -3 times what? -1. So 5 times -3 times -1. What would that be? 15. Positive or negative? Positive, because we have a negative times a negative, which makes it a positive. What do I want to multiply next? Why would I want to multiply A before B? Alphabetical order. So I'm going to multiply A squared times A cubed. So a to the 2nd power times a to the 3rd power. What do I do to the exponents? Add them. So 2 plus 3 is 5. And then I can multiply the b's. So I have b to the 4th power times b. What's the exponent on that second b? 1. What do I do to the exponents? Add them. So 4 plus 1 is 5. So my answer is 15 times a to the 5th power times b to the 5th power. All right, example 3 says be very careful with exponents, parentheses, and negative numbers. So looking at A. So these two parentheses are very different. Even though they look similar, they're different. So in the first one, what's being squared? Is that squared applying to the negative? No, it's just being applied to the x. So it's just that x that's squared. So that negative stays on the outside and it's just x squared. But with our second parentheses here, this one, what's being squared in the second one? Negative x. So that's like saying negative x times negative x. What do we know a negative times a negative is? A positive. What's x times x? X squared. Because what's my exponent on these x's? 1, and 1 plus 1 is 2. So it would be x squared. So it turns positive. So the first one is negative x squared. The other one's positive x squared. Now if I multiply these together, what would I start with? What's my answer going to start with? A negative. Because remember, this is just like -1, so I start with the numbers. And awesome. I would add my exponents, so it would be negative x to the 4th power. Perfect. All right, for B, it's kind of similar. In our first parentheses, what's that third power being applied to? Just the x, so that's just negative x to the 3rd power. In the second parentheses, what's that third power being applied to? The negative x, the whole thing. So that's like saying negative x times negative x times negative x. is negative x times negative x times negative x. Will that be positive or negative? Negative, because two negatives make a positive, but then when you multiply a positive number by a negative, it's negative. So this would be negative, and then how many x's do I have? So x to the third power. So then I'm multiplying these two together. What's a negative times a negative? Positive, so my answer will be positive. Awesome. What do I do to the exponents? Add them, so it'd be x to the 6th power. Example 4. Let's look at A. So here I'm multiplying and I'm adding, but what do I have to do first? According to PEMDAS, what comes first? Well, parentheses, but what am I doing in the parentheses? Multiplying. So I'm multiplying and I'm adding. Multiplication comes before addition. So for our first parentheses here, I want to multiply. What would I multiply first? 5 and 2. Start with the numbers, so that would be 10. And what is x to the 2nd power times x to the 3rd power? Awesome, x to the 5th power. Add the exponents together. So that's all I can do with the left side of the equation. Now let's look at the right. What do I multiply first? The numbers. 3 times 4? 12. What's x times x to the 4th power? X to the 5th power, because remember this has an exponent of 1. 1 plus 4 is 5, so x to the 5th power. Now I'm adding these together. How do I add them together? Ten plus 12, so 22. I keep the exponent the same, so it'll be 22x to the 5th power. So it's like saying I have 2 apples and 4 apples. That would mean I have 6 apples. I don't have 6 apples. So the exponent stays the same.
What if the exponents were like different?
Great question. What if the exponents were different? Let me do that on the side here. If I had x to the 3rd power plus x to the 5th power, what would I do here? Can I do anything here? Nope. These would be not like terms. So you can't add them. So this would be our answer. So the exponents have to be the same in order to add them. So just like we had x to the 5th power, x to the 5th power, that's why we can add the coefficients together, because our exponents are the same. If they're not the same, you can't add them together. All right, let's do B also. So what should I do first with B? Multiply 3 and 5. Perfect. I'm going to multiply, and I start with the numbers. So 3 times 5 is? 15. What would I do next?
Add 5 and 3.
Awesome. Add the exponents. So this would be a to what power? A to the 8th power. And minus. What would I do first on the right side? 6 times 1, which is? 6. And then what do I do with the a squared times a to the 6th power? Add the exponents. So it would be a to what power? A to the 8th power. Now, how would I subtract these together?
15 minus 6.
What's 15 minus 6?
9.
And then what would my variable be? What comes next?
A to the 8th power.
a to the 8th power. Perfect. It just stays the same. Because they're the same, it stays the same. So you just subtract the coefficients, the rest of it stays the same. Yes. Yes. But here we're raising a power to a power. So what would we do when we have a power raised to a power? We multiply. So when raising a power to a power, we multiply the exponents together. So it did an example for us. It says x to the 4th power to the 5th power. We multiply the exponent. So 4 times 5 is 20. So let's say I had x to the 3rd power to the 3rd power. What would this be? X to the 9th power, because I multiply the exponents together. All right, we're going to do the examples on the left. So I have p to the 6th power to the 4th power. What do I do to the exponents? Multiply. So what's 6 times 4? 24. Perfect. So our answer is p to the 24th power. All right, C is a little bit different because I have 2 things in my parentheses. So what do you think I have to do first? What would I do with the exponents? What do I do with the number? Perfect. I need to cube the 3. And what else am I going to do with the exponent? What else do I cube? The x squared. So I am distributing. So I distribute the exponent to both things inside the parentheses. If you have more than one thing inside the parentheses, you have to distribute. So this is 3 to the 3rd power and x squared to the 3rd power. So what is 3 to the 3rd power? So remember, it's 3 times 3 times 3. What's 3 times 3? Well, just 3 times 3. And 9 times 3? 27. So 3 to the 3rd power is 27. Be careful, you're not multiplying 3 times 3. It's 3 times 3 times 3. So 3 to the 3rd power is 27. Now I have x to the 2nd power to the 3rd power. What do I do when I have a power raised to a power? Multiply. So what would this be? X to the 6th power. So my answer is 27 times x to the 6th power. Any questions on what I did there? All right, let's take a look at E. What should I do first? Distribute that cubed. So I'm going to cube the 3. Cube the negative 3. Cube the x squared and cube the y to the 5th power. So this is negative 3 cubed, x squared cubed, and y to the 5th power cubed. So I distributed the 3. What is negative 3 to the 3rd power? Negative 27. Awesome. It's like negative 3 times negative 3 times negative 3. So this would become positive 9, and positive 9 times negative 3 is negative 27. What do I do when I have a power raised to a power? Multiply. So what's 2 times 3? So x to the 6th power. Awesome. And then what do I do when I have a power raised to a power? Multiply. So y to what power? Y to the 15th power. So in F, I have negative x y squared to the power of 0. So the whole thing's to the power of 0. what does the exponent of 0 do? What is anything raised to the power of 0? It doesn't make it 0, but you're on the right track. It makes it 1. So this whole thing is being raised to the power of 0, so my answer is 1. Yes. So if I had, let's say, my next example, G, if I had 999 to the power of 0, what would that be? 1. If I had 5 to the power of 0, what is that? 1. Example H. So there's one in the homework like this. Let's say I had 5 times x to the power of 0. What is this? What is being raised to the power of 0? The x. So that turns into 1. And what's 5 times 1? 5. So this would be 5. Right, going back to example B. So when we have two things inside our parentheses, we have to distribute so that third power gets distributed to the 2 and the x. So it'd be 2 to the third power and then x to the third power. So x with no exponent is like saying x to the first power. So we would multiply our exponents together when we have a power raised to a power. So it would be x to the third power. And 2 to the third power would be 2 times 2 times 2, which would be 8. And then same thing for D, we have to distribute that third power to the negative 2 and the x to the fourth power. So this is like saying negative 2 to the third power, x to the fourth power to the third power. So negative 2 to the third power is negative 2 times negative 2 times negative 2. We know a negative times a negative is a positive, so it would be positive 4. But positive 4 times negative 2 would be negative 8. And then here I have a power raised to power, so I would multiply 4 times 3 together, so it would be x to the 12th power. What do you think I need to do first for A? What do I do with the exponents? Yes, but I distribute. So you're saying the same thing, but in other words, I distribute. So I'm going to distribute that 3 to the 3, to the A, and to the B. So this is 3 to the third power times A squared to the third power times B to the third power. What is 3 to the third power? 27. What do I do when I have a power raised to a power? Multiply. So A to the second power to the third power would be what? A to the 6, because 2 times 3 is 6. What would my exponent on B be? 1, and 1 times 3 is 3. So B to the third power. Now I'm not done yet. Still have that second half. What do I need to do first on the right side? Distribute. So I have 2 to the second power, A to the third power to the second power, and B to the second power. So it's 2 to the second power. 4. What is A to the third power to the second power?
6.
Perfect. When you have a power raised to a power, you multiply. So that would be A to the 6th power. And what would my exponent on B be? 1, and then 1 times 2 is 2. Perfect. And then the last step is I multiply all of these together. So 27 times 4, if you don't know it off the top of your head, you can always write it down. 27 times 4, multiply it out the long way. 7 times 4 would be what? 28. 2 times 4, 8 plus 2. So this would be 108. So don't be afraid when you're multiplying big numbers. Just write it out. I can't do 27 times 4 in my head. I need to write it out. Some people can. But if you cannot, just write it out. Don't be afraid of big numbers. How would I multiply a to the 6th power times a to the 6th power? Add the exponent. So when you're multiplying, you add the exponent. So it's 6 plus 6. 12. So this would be a to the 12th power. And then what would I do to the b's? Add the exponent. So 3 plus 2 is 5. So it would be b to the 5th power. All right, let's take a look at b. So I'm multiplying everything together, but before I do that, I have to look at my parentheses. So since I have an exponent on the outside, I need to distribute that to everything on the inside. So I distribute it to the 2, distribute it to the x, and distribute it to the y. So this would be 2 to the 4th power times x squared to the 4th power times y to the 3rd power to the 4th power. So 2 to the 4th power would be 2 times 2 times 2 times 2, which would be 16. X to the 2nd power to the 4th power, we multiply these two together. So this would be x to the 8th power. Again, we have a power raised to power, we multiply the exponents together. This would be y to the 12th power. I'm going to do the same thing with the right side, so I need to distribute the 2 to the negative, and I distribute it to the x, and I distribute it to the y. So this would be negative 1, because negative 1 is our coefficient, squared, x squared, or I could say x to the 1st power to the 2nd power, and y to the 2nd power to the 2nd power. So negative 1 squared would be negative 1 times negative 1, which is positive 1. X to the 1st power to the 2nd power, and multiply my exponents together, so it would be x squared. And y to the 2nd power to the 2nd power. Multiply the exponents together, so that would be y to the 4th power. So 1 times x squared times y to the 4th power gets multiplied to everything else here. So then here I want to combine my like terms. So 16 times 1 is just 16, which in this step we didn't even need to write the 1 there, because if you have the coefficient of 1, you don't need to put it. Then looking at my x's, I'm multiplying x to the 8th power times x to the 2nd power, so I would add my exponents together, so x to the 10th power, and then with the y's, I have y to the 12th power times y to the 4th power, so I add my exponents together, so that would be y to the 16th power. So for A, looks a little tricky because I have a fraction, but what do you think I need to do first? Distribute the 3. So I distribute the 3 to what? To the x and to the y. So what would my answer be? X to the 3rd power over y to the 3rd power. That's it. So just because it's a fraction doesn't mean it's harder. You just distribute. Same thing we were doing before. All right, let's look at B. So take a look at B and D. There is a difference between these two. In B, what is being squared? Just the 4. So that negative stays outside. What is 4 squared? 16. In D, what's being squared? Negative 4. What is negative 4 times negative 4? Positive or negative? Positive 16, because a negative times a negative is a positive, so that's positive 16. So these two look very similar, but give you different answers, so just be careful. All right, let's look at C. In C, what's being cubed? Just the 4. So that negative stays out front. What is 4 to the third power? 64. Awesome. Again, if you didn't know it, write out 4 times 4 times 4. 4 times 4 is 16, and then we can multiply that times another 4, which would be 64. And then lastly, E, what's 4 to the power of 0? 1. Awesome.